everyone. Today we will be having our video assignment about parallel AC circuits, and we have three problems to be solved. So let's start. So good day everyone. Today we will be having a video assignment regarding parallel AC circuits. So we have three problems to be solved. So let's start. So the first problem is the direction first. Solve the below problems in a video and explain. So the first problem is two circuits, the impedance of which are given by Z1 is equal to 10 plus J15 and Z2 is equal to 6 minus J8 are connected in parallel. If the total current supplied is 15 ampere, what is the power taken by each branch? Find also the power factor of individual circuits and a combination. Draw vector diagram. So, naatay tulo ka ko ano ni. So, the first nga pangitaon is the power taken by each branch, and then next is the power factor of individual circuits and also the combination, and lastly is the vector diagram. So the first thing to do is let's identify the given based on the problem. So the given is the total current, which is 15 amperes. So let's just make the given to polar form. So we have 15 angle 0 degrees. Then the first impedance, or the impedance 1, is equal to 10 plus J15, which is in complex form. And then let's convert into the polar form. So let's input it in our calculator, and we will be having impedance 1, 18 angle 56.31 degrees. So that is the impedance 1. Next is the impedance 2, which is 6 minus J8. So it is also in a complex form. So let's convert it into polar form. So we have 10 angle negative 53.13 degrees. So that is the given for our problem 1. So the solution. First thing to do is get or solve for the total impedance. So the formula for the total impedance is Z is equal to Z1 times Z2 all over Z1 plus Z2. So since we already have the values for this from the formula, so we have already the Z1 here. This is the Z1, the 18 angle 56.31. So, ang akong gibutan diri kay ang complex form lang sa. So, the complex form for Z1 is 10 plus J15 multiplied by the Z2, which is the 6 minus J8. And then, to add this Z1 and Z2, so 10 plus 6 is 16, then 15 minus 8 is 7. So we have 16 plus G7. So to input this in our calculator, we will be having a 9.67 minus J 3.61. So that is in the complex form. And to convert it into polar form, we have 10.3 angle negative 20.4 degrees. So that is for the total impedance. Next is applied voltage is given by, so this is the formula for our voltage. V is equal to the product of our current times the total impedance. So since we already have our current, so this one, 15 angle 0 degrees, that is the total current. And the total impedance nga to na-solve a while ago, which is this 10.3 angle negative 20.4 degrees. So let's input it on our calculator. So we have 15 angle 0 degrees times 10.3 angle negative 20.4 degrees. So we have 144.81 minus J 53.85. So that is the complex form for the voltage. So we will be converting it to polar form, so we have 154.5 angle negative 20.4. So that is the applied voltage. So next is we will be solving the individual circuits. So the circuit, I mean the current, individual current. So the current one is from the formula here, V is equals to IZ. We will divide both sides by Z. So we have the formula for our current. So I1 is equal to V over Z1, since naa siya specification nga 1 ang atong first nga current atong kwaon. So I will be using the impedance for the impedance 1. So we have V over Z1. So let's substitute the values from the formula. So we have 154.5 angle negative 20.4 degrees over the impedance 1, which is here 18 angle 56.31 degrees. So input it in the calculator and we'll be having a answer 8.58 angle negative 76.71 degrees. So that is for the current 1. Next is for the current 2. So for the current 2, we have V over Z2, the same formula but different values. So for the V is 154.5 angle negative 20.47 here, and next is 10 angle negative 53.13 degrees. So input in the calculator and we'll be having an answer 15.45 angle 32.66 degrees. So that is the individual current for this problem. So next thing to do is the solve for the power of each brand. So we have the formula for the real power. We have P1 is equal to I squared times R1. Or for general formula, we have P is equal to the current squared times the resistance. So since we will solve for the individual or the power of each brand, so we will specify this. So we have P1 is equal to the I1 squared times the resistance 1. So we have the I1 8.58. So we have 8.58 squared times our resistance here from the impedance, which is 10. So we have 10. So 8.58 squared times 10. So we have the answer 736.16 watts. So we have watts here for the unit of our power, since it is the real power. So next is solve for the individual power factor. So the formula for a power factor is a cosine theta. So cosine, so we have here 56 for the P1. We have 56.31 here from the impedance 1 angle. So we have cosine 56.31, so 0.555. So I label it log, but later on I will discuss why it is log. So based on the vector diagram also. So next is for the P2. So for the power of the 2, so the same formula but specify it for the 2. So I2 squared times the resistance 2. So we have here 45 squared for the current for I2, or the current for 2 is there 15.45, and the resistance for the 2 is 6 here. So multiply it, 15.45 squared times 6 is, we have 1432.22 watts. So that is for the power 2. Next is for the power factor. So the same formula. Then different for the angle, we have for the here in the impedance 2, we have 53.13. So cosine 53.13. So we have 0.6. And then the combined power factor, we have cosine theta. And the theta we will be using is from this total impedance, we have 20.4. So cosine 20.4 is equal to 0.937, and that is lead. So later on also, we will be having the vector diagram. So that will be discussed. So here, this is our vector diagram. So we have here the labels. So first is the our total our total current is 15 ampere. So as we can see in the last slide, we have the 15 ampere. The angular 15 ampere is 0. So since it is 0, so we have here in the x-axis. So the next is for our voltage. So the angle of our voltage is negative 20.4. So since it is negative, so mo down ta. So we have 20.4. And the next is for the current one, we have 8.58 ampere. Since the angle of our current one is negative 76.71, so we will also down here. So we have here 76.71 from the 0, or for the x-axis, down to the fourth, like the fourth quadrant. So here, so we have 76.71 degrees. And next is for the I2, or for the current 2, since our angle for the current 2 is positive 32.66, so pa-up siya. So we have 32.66 above our total current. So that is our factor diagram. So proceed for the next problem. We have here two impedance Z1 is equal to 8 plus J6, and the Z2 is 3 minus J4 are in parallel. If the total current of the combination is 25 amperes, find the current taken and power consumed by each impedance. So the given, same process. So first, let us identify the given. So our total current is 25 amperes. So let's make it to the polar form. So 25 angle 0 degrees. Then for the Z1, or the impedance 1, we have 8 plus J6. And then since it is a complex form, so let's convert it into polar form. So we have 10 angle 36.87 degrees. And for the Z2, or the impedance 2, we have 3 minus J4 in complex form, and let's convert it into polar form. We have 5 angle negative 53.13 degrees. So we already have the given, so solution. First is the total impedance. So the formula for the total impedance is Z is equals to Z, the product of Z1 and Z2, all over the sum of Z1 and Z2. So substitute the values from the formula. So we have 8 plus J6 for the impedance 1, and the Z2, or the impedance 2, is 3 minus J4, and all over, let's get the sum for the Z1 and Z2. So we have 8 plus 3 is 11, then 6 minus 4 is 2, so 11 plus J2. So to input it in our calculator, we have 4 minus J2 in complex form, the answer, and we will convert it into polar form. We have 4.47 angle negative 26.57 degrees. So applied voltage is given by, so we will solve for the voltage. V is equal to IZ. Our I is the current, and Z is for the total impedance. So since it is already given, so we will just substitute. So our current is 25 angle 0 degrees, and the total impedance is 4.47 angle negative 26.57 degrees. So to solve this, input it in the calculator, and we will have 99.95 minus J 49.98. So it is in complex form. And then also, to convert it into polar form, we have 111.75 angle negative 26.57 degrees. So that is the voltage. Then next, to get the current, we will need the voltage. So mo na atong solve first ang voltage. So the voltage over the impedance 1 for the current 1. So substitute the values. We have the voltage here, 111.75 angle negative 26.57 degrees over the impedance 1 is 10 angle 36.87 degrees. So we have 11.175 angle negative 63.44 degrees. So next is for the I2 or the current 2, we have V is equal over Z2. So same formula. So we have 111.75 angle negative 26.57 degrees over 5 angle negative 53.13 degrees here. And the Z2 or the impedance 2. So to solve this, input in the calculator and we'll be having an answer 22.35 angle 26.56 degrees. So that is for the current 2. Next is we will solve for the difference between the V and the I1. So that is the phase difference between V and the I1. So we will just um, minus, so negative 26.57, which is the V here, negative 26.57, and the I1 is negative 63 minus 63.44, which is here for the I1, the angle for the I1. So we have negative 36.87. So cosine to get this, so we will use cosine phi. This is the symbol for phi. So cosine phi 1 is equal to cosine negative 36.78. So the answer is 0.8. That is for the cosine phi. So we'll be using it to get the power consumed in Z1 by the formula P1 is equal to VI1 cosine phi. This formula. So P1 is equal to VI1 cosine P1. So we have 111.75, which is the voltage here, voltage. And then for the current, for the I1 is 11.175. Then multiply it by the cosine phi, which is 0.8. So we have here 111.75 times 11.175 times 0.8. So we have 736.16 watts. So that is the power consumed in the impedance 1. Next is the same process. Find the phase difference between the V and the I2. So I2 na sa diri. So negative 26.57 minus 26.56 is equal to negative 53.13. Then cosine phi 2 is equal to cosine negative 53.13. So we have 0.6. Then power consumed in impedance 2, we have here this formula. P2 is equal to VI2 cosine P2. So we have 111.75 times the 22.35 here for the I2 and 0.6 for this, for the cosine phi 2, which is 0.6. So 111.75 times 22.35 times 0.6, we have 1498.57 watts. So that is the answer for the number 2, which is the the question asked, find the current taken and the power consumed by each impedance. So this is the answer, and the current taken here for the um given. So we have I1 and I2. So next problem, we have here refer the circuit figure 14.10a and determine the resistance and reactance of the lagging coil load and the power factor of the combination of the currents are as indicated. So this is the figure 14.10a. That is the figure. So next, solution. So this is the diagram. So this line AB is the current for our resistance. So since it is in the x-axis or the 0 degrees angle, tay, as we all know, resistance 0 ang iyahang degrees if ingani siya. And then it is in the 0 degrees since it is katong sa purely resistive load nga ang flow sa iyang current is in 0 degrees. So we have here in the x-axis. So and also for the source 100 voltage, and then 4.5 amperes which is ang ato ang sa impedance or for the inductance na to lag na siya sa ubos, so lag siya. So since kuan man siya current siya nga ni flow padung siya sa atoang sa atoang inductance or sa inductive na to. So it is the purely inductive load. So mo na siyang lug. Inductor lugs the voltage across to 90 degrees. Mo na siya. And then for the 5.6 amperes, also the current the current from our voltage we have here. It stands as the resultant in the parallelogram figure. And then here for our broken lines here to form this as a parallelogram. So we have our phi and our theta. So the formula for this one is from the formula of parallelogram law of forces. The resultant squared is equal to the a squared plus b squared plus 2ab cosine theta. So our a, let's assume our a is here from the line A to here, which is the 4.5, and the b here is from the AB, which is the 2 amperes. So let's substitute the values from the formula. So we have the resultant, which is this line, which is 5.6 ampere. So 5.6 squared is equal to the A here, 4.5 squared plus 2 squared, which is the 2 amperes, plus 2 times 4.5 times 2, which is the AB, and then the cosine theta. So our ato isuban is ang cosine theta. So since it is addition, so atong gi-transpose sa pikas na side. So mo na siyang 5.6 squared minus 4.5 squared minus 2 squared is equal to 2 times 4.5 times 2 cosine theta. So the answer for this is 7.11, and the 2 times 4.5 times 2 is 18. Then divide both sides by 18 to get the cosine theta. So we have cosine theta is equal to 0.395. So that is the cosine theta. So next is let's solve for the theta. So cosine theta is equal to 0.395. Then the theta, let's inverse cosine. So cosine power of -1 times 0.395 is our theta is 66.734. So to get the sine theta here, let's substitute the theta. So sine 66.734 is 0.919. That is for the sine theta. So solve for the impedance. So since ang ipangita po nato determine the resistance and the reactance man, so we need to first identify the impedance. So the impedance is from the formula V is equal to IZ, we have Z is equal to V over I. So V is 300 voltage here, and current is 4.5 ampere, since it is for the current for our impedance here, which is the 4.5 ampere. And then divide this. 300 divided by 4.5 is 66.67 ohms. So that is for the impedance. Next is for the resistance. So our resistance, the formula for our resistance is R is equal to Z cosine theta. So R is equal to Z cosine theta. So 300 cosine, our theta here is 66.734. Asa na siya gikan? So, mo na siya, kani, cosine theta, which is the theta, so the theta is 66.734. Then the cosine 66.734 is 0.395. So we have 300 times 0.395. So we have 118.5 ohms. So that is for the resistance. And lastly, for the power factor of the combination, we have PF is equal to cosine phi. So our power factor is a cosine phi. So we have here, for the cosine phi, since mo siyang phi na to diri sa itong diagram, so we have AC and AD. Then, for the AC, we have 2 plus 4.5 times 0.395 all over. So since we already have the AD, which is 5.6 amperes, so 5.6 amperes. So 2 plus 4.5 times 0.395. So we have 3.7775 over 5.6. So our answer is 0.67 for the power factor, and it is in log because, as you can see here in the diagram, we have here the voltage, and then our power factor is here, so it is below or under for our voltage, so we have here the 0.67 log. So that is all for the video assignment, and thank you for listening. Have a good day.